Good morning, Dylan.
Good morning.
Dylan, are you there?
Yes, ma'am.
Alrighty. Good morning, Miss Grace.
Hi.
Did y'all get to practice some more related rate problems this weekend?
Mhm.
How are you feeling about them after some more practice?
Eh.
I promise not to give you the hardest ones. Good morning, Miss Autumn.
Morning.
Joseph, can you hear me? I was trying to let Joseph get his mic fixed before I started, and it's not showing up. Well, maybe he can hear me. All right. Just a couple of reminders before we get started. One being that the test is coming up Tuesday, and I'll have it set where you can access it and take it from 8 to 10. I still haven't started making it, but I will make it before Monday so that Monday I can give you a good idea of what it's going to look like. And we've already discussed it a little bit, but I may ask you to take a picture of your work and send it to me. Section 4.3 was on the first derivative test. You look at the first derivatives to answer questions about what? What can you tell by looking at the sign of the first derivative? Miss Autumn, what can you tell by looking at the sign of the first derivative?
Doesn't that tell you like what direction it faces, like up or down from the?
Okay, increasing or decreasing. So if you have questions about is the function increase or where is the function increasing, where is it decreasing, then you'd use the first derivative test. Based on where the function is increasing and decreasing, what other important information can you get? Let me say where the function goes from increasing to decreasing. What can you tell? Mr. Dillon?
You can tell like mins and max.
Yeah, there's going to be a relative max there, and where the function goes from decreasing to increasing, there's going to be a relative min. So to answer those questions about relative max and min and where the function's increasing, where the function's decreasing, you look at the first derivative. What do you look at the second derivative for? It answers questions about what? Joseph? Joseph,
I'm
can you
not
hear?
really sure to answer that.
Look at the title of the section. What does the second derivative test tell you about?
Oh, concavity.
Yeah, concavity, where the second derivative is positive. That tells you your function is concave which way?
Wait, say that again, sorry.
If your second derivative is positive, what does that tell you about concavity?
It's concave up.
Concave up. Second derivative negative is concave down. All right, so y'all have watched the video already. One thing that I'm pretty sure I said in the video, but certainly want to make sure you understand, the second derivative test tells you how to, or gives you another way to find absolute max and min. Not absolute, relative max and min. You don't ever have to use the second derivative test. If you have a question about increasing or decreasing, you can find relative max or min without having to find the second derivative. The only time I use the second derivative test is when you don't have to answer any questions about increasing and decreasing, and when it's easy to find the second derivative. Basically, if you just give me a polynomial function and say where are the absolute max and min, and that's or relative max and min, and that's all you ask me, I might use the second derivative test for that. But actually, I use that very, very rarely. One other note, and then I'll take any questions you have from the homework. I have the question help tools in my math lab set to only be accessible during review mode. So if you miss a problem, before you email me about it, go to Gradebook and click review, and then use one of the question tools. Use help me solve this, and it'll break that problem down into baby steps for you. Do that, and if you can't figure it out after that, then click ask instructor, send it to me, and send me a picture of your work. All right. What do you need to ask for from the homework? Page 436. I'm a little afraid to ask whether that means if you've done the homework and don't have any questions, or you haven't done the homework yet. Does anybody try it and have a question for me? Okay, let's do it this way. Miss Grace, have you tried the 4.4 homework?
A bit.
A bit, okay. Joseph?
Yep, I did a little bit of them.
Okay, and so you understand how concavity works?
Yes, ma'am.
All right, Autumn?
Yeah.
Dylan?
Yeah, I started, but I didn't quite finish
Okay.
everything.
Okay. Mackenzie, good morning.
Good morning.
Do you have any questions from the homework?
No, I'm good.
Okay. It's not hard to apply the concept of second derivative and what it tells you about concavity. It's just sometimes finding the second derivative is a bear. Oh, I thought of one other thing to ask you. What do you call the point where the concavity changes?
Was it
Where the
inflection?
graph stops being concave up, for example, and that's concave down, I'm sorry, stops being concave down and starts being concave up. What do you call that point?
An inflection point?
Yeah. So if you were given a number line that already had your critical points on it, critical points for either the first derivative or the second derivative. Let's say you had 3 critical points, A, B, and C, and you looked at the sign of the first derivative and the sign of the second derivative in each one of those intervals, which, darn it, I didn't leave myself enough room there. Let's say the first derivative is positive and the second derivative is positive. What does that tell you about the function? And I'm looking for words about increasing, decreasing, concave up, concave down. Is the function increasing or decreasing to the left of A?
Decreasing.
I didn't hear you. Say that again.
Decreasing.
Decreasing? Where the first derivative is positive, that's increasing. Where the first derivative is negative, that's decreasing. So where the first derivative is positive, that means that interval on the graph is increasing. And by the way, make sure, I mean, I barely left myself enough room here, but make sure your sign of the first derivative and sign of the second derivative aren't right over the critical point A. That's to the left of A. From negative infinity up to A, the function's increasing. And what do you look at to determine the concavity of the graph up to A? Somebody say second derivative.
Second derivative.
Okay, so the function's increasing and concave up to the left of A. Can you, on your own paper, can you sketch a little piece of graph that is going uphill left to right and it's concave up? Try that. Increasing means going uphill from left to right. Concave up means, actually, technically, it means that the slope of the tangent line is increasing. The tangent line is steeper here than it is there, and that's why it's concave up. But if the first derivative is positive and the second derivative is negative. What does that tell you about the function?
It's increasing and it's concave down.
Right. And I wrote concave like it was 2 words. Can you draw a portion of the graph that is increasing and concave down? Still has to be going uphill from left to right, but concave down. Think of the left-hand side of a concave down parabola. And then what if from B to C, the first derivative was negative, but the second derivative was positive? What would that tell you?
Decreasing and concave up.
Yep. So it's going downhill left to right, but it's concave up. You can think of the left-hand side of a concave up parabola. And then to the right of C, if both derivatives are negative, what does that tell you?
Decreasing, concave down.
Decreasing and concave down. Going downhill from left to right, but concave down. Like that. Hey, looking at that sign chart, tell me where there's a relative max. How can you tell by that graph where there's a relative max?
Would it be at point B?
Because why?
Because it goes from increasing to decreasing?
That's exactly right. Where the function goes from increasing to decreasing, there's a relative max. And what about a relative min?
Both A and C.
At A, the function was increasing and it kept increasing. Is there going to be a relative max if the function's going uphill and it keeps going uphill?
No.
No. And not if it's going downhill and keeps going downhill. There's only relative max and min where the sign of the first derivative changes. So there's a relative max at B, but there's no relative min on that graph. What about inflection point where the concavity changes?
Is that A and C?
Yes. Trying to think of something I can do. I can't think of anything I can put on my chart that won't just make it messier. A and C, where the sign of second derivative changes. All right, sounds a little bit like y'all have some work to do. Remember, well, I've already put the 6 problems for today's homework online. Remember that if you try it once and miss it, look at the question help, the help me solve this. And if you still can't get it, take a picture of your work and email me that and the question. Click Ask Instructor and it'll send me the question. All right, do y'all have any other questions? Going once, going twice. All righty, y'all have a good day.
You too.
Bye-bye.
Bye.
Bye-bye.